Prime factorization. We love prime factorization. This is actually kind of fun. You may not agree with me, but it actually kind of is. So prime factorization, this is one of those vocab words we just have to understand and remember what they're actually asking us to do here. When you see prime, that means that our final answer is going to have prime numbers. Factorization means we're going to look to break down our numbers 28, 32, 18 into factors until we get the prime numbers. So this is your factor tree. When I say factor tree, you guys remember what that is, but it's not going to say factor tree on any quizzes or tests, so we have to remember what prime factorization means and that is the same thing as your factor tree. So here's how this works. You take a number like 28, and we're going to break it down into a set of factors. You can pick any factors you want other than 1. 1 and 28 doesn't necessarily help us out, but you could pick 2 and 14, 7 and 4. Those probably are the only ones you could pick. So let's say we pick 2 times 14. So 2 and 14 are factors of 28 because 2 times 14 equals 28. And now what we're going to do is we're going to break these down until we get to prime numbers. So 2 is a prime number. The only factors of 2 are 1 and itself, so that is what makes it prime. 14, however, has more factors besides 1 and 14, so this we can break down into some more factors. So what goes into 14? Well, 2 times 7, 2 and 7 are factors, and then we look to see, are these prime? So 2 is a prime number, and 7 is also prime. 7 does not have any factors besides 1 and itself. So if you notice, we have nothing left to break down, which means we've done our factor tree. So that's kind of the work you show. Your final answer, however, will be, there's 2 ways to write it. We're going to write out our prime factors. You do want to make sure that you go in order of smallest prime number to largest prime number, okay, in increasing order. So we did 2 times 2 times 7. Or if the directions ask for this using exponents, then we can take that 2 times 2 and just clean that up a little bit. Your base is 2, and we're multiplying 2 of them, so 2 to the second power times 7. So this is the prime factorization, and we used a factor tree to get that. Alright, 32. Let's break down 32. So factors of 32, 4 and 8 come to mind first for me. 4 times 8 is 32. Now I look at 4 and 8. So 4 is not a prime number because it has more factors besides 4 and 1, so that means I can break that down. 4 is equal to 2 times 2. So 2 is prime. We talked about that last one, so that one's done. Now 8 breaks down into 4 times 2. Oh, there's that 2. I'm going to circle that prime number, but that 4 is not done. We can break that down. 4 is equal to 2 times 2, and those are our prime numbers. So if you notice, we don't have any branches of our factor tree to continue factoring, so this is it. We have all of these 2's. We're going to write it out. 2 times, we count it up, we have 5 of them. So there's the prime factorization, or if they want you to write it using exponents, that base is 2, and we're multiplying 5 of them, so 2 to the 5th power. Alright, last we have 18. So we are going to break down 18. You could do 2 times 9, you could do 6 times 3. That's probably all you can do. And it does not matter which one you pick. In the end, you're going to end up with the same prime numbers. So maybe I'll go 6 and 3. 6 times 3 is 18. Well, 3 is prime. There are no other factors besides 1 and 3. So that one's done. 6, we can keep breaking down. 6 is equal to 2 times a 3. 2 is prime and 3 is prime. So that one's done. We write it out, smallest prime number first, 2 times 3 times 3, and then if we're looking for exponent form, 2 times 3 squared. And there is your prime factorization.